Hey guys, got another screencast in the serverless series for Lambda functions on Amazon. Today we're going to focus on creating a RESTful endpoint for a put request against a Lambda function, which is going to store a record in a DynamoDB table. So we're going to continue on with the blog post that demonstrated how to do this, and we're going to move down to the right portion of the blog post. Now, as you can see, they're telling you go ahead and create a function, and they go through all the steps. And what I'm going to do is go ahead and demonstrate that. So at the Lambda Management Console, we're going to go ahead and click Create Function. We're going to author one from scratch. In this case, we're going to name it specifically what its function is. In this case, we're going to put a task. And under permissions, we expand the choose or create an execution role, and we're going to create a new role using AWS policy templates. And this probably looks a little different from the blog post that we're going through. So we're going to give this a role name that describes exactly what this function does. In this case, it's a put task role, and under policy templates, we're going to select simple microservice permissions. And this is a pre-built template for permissions that Amazon has provided us that helps us connect a Lambda function to a DynamoDB table. So we're going to go ahead and click Create Function. It may take a moment because it has to also create this new role, and this new role will show up in the IAM Management Console. So we'll go look at that in just a moment. Okay, so our function has been created. Let's jump over to IAM and let's click on the roles option and let's refresh. And you'll see there's a new put task role as defined in our function. Okay, so now our function has been created, and we go down and see that there's basic template code, boilerplate, that's been put in there for us. And I'm going to jump over to my notepad where I've already written the code that goes in here. I'll copy that and paste it in. And let's talk a little bit about the code to begin with. So as we said earlier in class, a Lambda function is a function. And in essence, this anonymous function here is where we define the functionality of the Lambda event. So in here, when the Lambda function is first created, it logs that the function is started. We're including in it two different libraries. One is the AWS SDK library. The other is the doc client object, which we're creating from the AWS library. We then go into the function that handles the event, and it displays to the log the event and the input that came into it. We create a JSON object called parameters, and inside that we have all the parameters that are necessary to perform the update on the DynamoDB table. So what we need to define is the table name, in this case tasks, the key, which is how it locates which document in the table to update. In this case, it locates it based on the list ID. And from the event, we get the list ID attribute and set that to the value for the key. Then we have an update expression that's very similar to parameters that we would set on a prepared statement in SQL. In this case, we set a field name equal to a value, a field name equal to a value, and so on. And each of these values are just placeholders like we have in a prepared statement that we then set attributes to. So we associate the event task name with the task name placeholder, the event task date with the task date placeholder, and so on. Then lastly, we use the doc client to perform an update, passing in the parameters, and in the event that an error occurs, it will perform the callback function with the error. Otherwise, it will perform a callback function with data. And in this case, data has been set to nothing, so it will basically return a null value. So we go ahead and save our function, and then we need to test it to see what it's going to look like. So up here at the top we have our test events, and for a new function we have to configure a test event for the first time. So I'm going to go back over here to Notepad, and I'm going to grab a sample task that I would like to update, and I'm going to paste it in here, and I'm going to pick an ID that already exists in the database, such as 1234, give it a new name, such as update task, and set it to a new date. And I'll create this test event. Now, of course, I need to give it a name, update task, create that. And now we have an update task test event. We can create multiple test events for each type of test we'd like to run. For example, if we wanted to test a problem with events that don't have all the attributes they need, or it has invalid data, then we could create a different test event for that. Anytime you test something and you expect a problem to come from the test, we call that a negative test. So with that test selected, we click the test button, scroll up to the top, and it shows you the results of running the test. In this case, it shows processing event, and then it returned a success, which is why we see a green box here. Had it failed, it would have displayed in red. So we'll go to our DynamoDB table. We're looking at the task table. We're going to refresh, and we'll see the task itself. Now, the interesting thing is that a update request will actually create a task in the event that the task does not already exist. So it's an interesting side effect that an update event can create a new task as well as update an existing one. And if we look at the task itself, we can go to the raw JSON, and you can see this looks exactly like the test event that we passed in. Okay, so that concludes creating a basic function. We'll have additional screencasts in which we'll validate the data, we'll handle errors, and so on.